Assalamu alaikum. In this video we will learn about the mole calculations, that how will we find the number of moles, right? Number of moles. In the previous video I told you three formulas. I hope you all remember those formulas. The first formula was number of mole is equal to mass in gram divided by molar mass. This was the first formula. The second formula was that number of mole is equal to number of particles divided by Avogadro number. And what was the value of Avogadro number? 6.023 multiplied by 10 raised to power 23. Right? How can you learn this? Learn only 6.0, right? And 2.3 over here. This 2.3 is also at the top of the power of 10. Right? So you have to learn 6.023 multiplied by 10 raised to power. The same last two digit will be on the power of 10. So in this way you can learn the Avogadro number. And what was the third formula? Third formula was related to the number of moles and volume in STP. We learned that number of moles is equal to volume of gas at STP divided by molar volume. Molar volume at STP. What was STP? STP was standard temperature and pressure. And what were the values of STP? I already told you in the previous video. But let me also tell you the value of molar volume. What was it? It was 22.4 dm cube per mole. Now let us go towards the mole calculations. The very basic things that we should know for calculating the number of mole is the molar mass. Molar mass. Molar mass for which formula? For this one. And also in this case, in case number 2, we will already be given the number of particles. If we are not given the number of particles, we will know the number of moles, and with the help of any of them we can find the other number. First we will solve the numericals regarding to this formula. So for this we should know about the molar mass. Also studied the molar mass in our first lecture, but let me again briefly tell you that how will we find the molar mass. In the previous video I told you that first you have to write the formula. Let us take the water molecule. Right? Now we should know the atomic masses. Okay? What is the atomic mass of oxygen? It is 16. And what is the atomic mass of hydrogen? It is 1. Now hydrogen is equal to, how many hydrogens are present? 2. And 2 multiplied by what is the atomic number? 1. It will be equal to 2. Oxygen is equal to, what is the atomic mass? 16. Or we can write the number of oxygen or atomic mass, whatever before. So here I am writing the number of oxygen present multiplied by what is the atomic mass? 16. So it will be equal to 16. When we will add both of them, we will get an answer 18. And when we will write it in terms of molar mass, we will write gram per mole. Right? So this will be the molar mass, and this is how we will calculate the molar mass of all the other substance. Now before starting the mole calculations, I would like to tell you that how you will attempt these numericals in your exams. First you will write the question, then you will give the heading of data. Okay? Now in the question there will be one thing that will be required, like you have to find the number of moles or you have to find the number of particles, etc. So you will give the heading of required. Okay? Then after writing this you will give the heading of solution. And after solution directly give the heading of formula. After doing all the calculations, give the heading of result. Now the first numerical that I am going to discuss is, so how will we find the number of moles in 2 gram of oxygen? We know the formula that number of moles is equal to mass in gram divided by molar mass. So in this case, what we have to find? We have to find the number of moles, and we already know the mass in gram, and we can find the molar mass by ourselves, right? Now let us first find the molar mass. What is the atomic mass of oxygen? It is 16. And how many oxygens are present? 2. So 2 multiplied by 16, which will be equal to 32. And for molar mass, we will write the unit gram per mole. Let us see, the number of moles will be equal to 2 gram divided by 32. Here n will be equal to, after cutting it, we will come to know that number of moles will be equal to 1 by 16. Okay, and we will write the unit mole. So this is how we will find the number of moles. You can further divide it and write the answer in decimal form as well. Now the next example that I am going to discuss is that how many number of moles are present in 60 gram of sodium hydroxide. For this we will use the same formula, that is number of moles will be equal to mass in gram divided by molar mass. First we will find the molar mass. For the molar mass, we know that we should know the atomic masses. The atomic mass of sodium is 23. Right? Let me write over here 23. The atomic mass of oxygen is 16 and atomic mass of hydrogen is 1. Okay? These are the atomic masses. Now, molar mass, how many sodium is present? 1. So we will write, and 1 multiplied by what is the atomic mass? 23. Okay? How many oxygen is present? 1. And what is the atomic mass? 16. Now the last one is hydrogen. How many hydrogens are present? 1. And what is the atomic mass? 1. Right? We will write it in this way. Now when we will add all these, we will get an answer 23 plus 16 plus 1. And this all when we will add, we will get an answer 40. And when we will write over here gram per mole, then this will be the molar mass of sodium hydroxide. Now what we have to find? We have to find the number of moles. Now we have the mass over here. Now we already calculated the molar mass. Now we will put the values. Number of mole will be equal to mass in gram, which is 60 gram divided by 40 gram per mole. This gram and gram will cancel each other, and this 0 and 0 we can cancel it, or we can directly divide them. Then we will be left with 6 and 4. When we will divide these, we will get an answer 1.5 mole. Okay, so number of moles, we get to know how many number of moles are present, 1.5 moles. Now let us go on to the next numerical. I hope you already understood the first formula, that how will you do the calculations, but let us see that how can we find the number of moles from the mass given. How much mass is present in 5 moles of calcium carbonate? In this case we are already having the moles and we have to find the mass. Okay, the formula will remain the same. It will be number of moles will be equal to mass in gram divided by molar mass. Okay, now what will happen? That we will rearrange this formula. This mass will stay in its place and this molar mass will go on the other side. It is in division form. On the other side, it will multiply with the molar mass. So after rearranging the formula, it will be in this way. Number of moles multiplied by molar mass, which will be equal to mass in gram. Now we have this formula, which is the rearranged form of the main formula. We are already having the number of moles and we can find the molar mass, right? Note this formula. Let's first calculate the molar mass. Molar mass of calcium carbonate. Atomic mass of calcium is 40, atomic mass of carbon is 12, and atomic mass of oxygen is 16. Till now at least you have learned the atomic mass of oxygen because we have used it in many examples. So 40, 12 and 16. How many calciums are present? Only one. So 1 multiplied by 40. How many carbon is present? 1. We will put the plus sign over here and 1 multiplied by 12. Then how many oxygens are present? We will put the plus sign and then we will write 3 oxygens, which will multiply with the atomic mass, that is 16. When we will multiply and add all these, we will get an answer 100 gram per mole. The formula that we rearranged was that mass is equal to number of mole multiplied by molar mass. Now, number of moles is already present in the question, that is 0.5. We will multiply it with the molar mass, that is 100 gram per mole. Okay? Now, here it's mole. You can see over here that if we write it in the other form, it's like this, 100 gram per mole, right? So this mole and this mole will cancel each other and we will be left with gram. So after calculating this, we will get an answer 50 grams. So mass in gram that we found is 50 grams in 0.5 moles of calcium carbonate. Now the next numerical that I am going to start is that in a certain experiment 8.50 multiplied by 10 raised to power 25 molecules of water were used. Calculate the number of moles of water. In this case we are given the number of molecules. So which formula we will use? We will use the formula that number of moles is equal to number of particles. We are given with number of molecules, so we can write here number of molecules divided by Avogadro number, right? Now when we will put the values, we will get the number of moles. So number of molecules is equal to 8.50 multiplied by 10 raised to power 25 divided by 6.023 multiplied by 10 raised to power 23. When you will divide these, you will get an answer 1.41. Okay, and this 10 raised to power 23 will go on the upper side and it will be like 10 raised to power 25 minus 10 raised to power 23. Here it is in plus form. So when it will go on the upper part, it will be in minus form. So 25 minus 23, we will get 10 raised to power 2. And as we have to find the number of moles, so we will write over here 10 raised to power 2 moles. So this will be the number of moles present in 8.50 multiplied by 10 raised to power 25 molecules. Now in this example, see that how many formula units are present in 125 gram of hydrated copper sulfate. It is not simple copper sulfate CuSO4, it is in hydrated form. Have a look that we are given the mass. We are not given the moles, from which we could easily calculate the formula unit. In the formula of number of moles, which is equal to number of formula units, here we can write in place of particles formula unit divided by Avogadro number. So we are not given the number of moles, we are given mass in gram. If we were given the number of moles, we could easily find the number of formula units by rearranging the formula and taking the Avogadro number on the other side, where it would multiply with number of moles. So from this formula, we can see one thing, that we have to find the number of moles. So we will convert this mass in gram to the number of moles. First of all, we will find the number of moles, which is equal to mass in gram divided by molar mass. We know the mass in gram, which is equal to 125, and we have to find the molar mass. So we have to find the molar mass of hydrated copper sulfate. Let us first find the molar mass. Molar mass is equal to, first we will write the atomic masses of all. The atomic mass of copper 64, the atomic mass of sulfur is equal to 32, the atomic mass of oxygen is equal to 16, and we know the atomic mass of hydrogen, which is equal to 1. So let's calculate the formula mass. We will start with copper. How many copper are present? 1. So 1 multiplied by 64. Then sulfur. How many sulfur are present? 1 plus 32 multiplied by 1, or 1 multiplied by 32 plus oxygen. How many oxygens are present? 4. 4 multiplied by 16, then plus sign, and 5. 5 of water molecule. After this, we will write the number of hydrogens present, that are 2, multiplied by its atomic mass, that is 1. Then we will add, what is the atomic mass of oxygen? It is 16. So in this case, what we will do, that we will multiply this and this. We will write their answers, plus we will write 5 in its place, and we will multiply first this and plus 16. Now we will first calculate this bracket, and it will be 5 into 18. 16 plus 2, 18. After adding all these values, you will get an answer that will be equal to 250. Okay, 250 gram per mole. So now we calculated the molar mass, and we know the mass in grams. So now we can calculate the number of moles. Remember one thing, that if you want to find the formula mass or molecular mass, you will go with the similar procedure of adding and multiplying their atomic masses. Then you will write the unit AMU. Okay. Now for copper, the answer was 250. So if you will write in the form of formula unit, you will write 250 AMU. And then you will write a statement that when AMU is replaced by gram per mole, then that answer will become the molar mass. Okay. Now we have find the molar mass. So number of moles was equal to mass in gram divided by molar mass. Molar mass was equal to 250 gram per mole. So we will write over here 125 gram divided by 250 gram per mole. Then we will have an answer of 0.5 mole. Okay. Now we have the number of moles. So now we can calculate the formula unit present in 125 gram or 0.5 moles of hydrated copper sulfate. Now the rearranged formula that we did was equal to number of moles multiplied by Avogadro number, which is equal to number of formula unit. Right? So now in this case, we are having now number of moles, which is equal to 0.5 multiplied by Avogadro number. So when you will calculate this, you will get an answer of 3.011 multiplied by 10 raised to power 23. So this is the number of formula unit present in 125 gram of hydrated copper sulfate.